Hello, my name is Michael Lee, and welcome to the new SAT Math Concept Lecture. Today we will be covering the foundations, very simple things that we will be going over, but very vital in order to do really well on the SAT. If you watched the introduction concept lecture or the introduction video, you might have noticed that there were a lot of questions that have to deal with basic concepts such as linear equations, being able to solve algebra problems and such. And today we will be covering most of those concepts. So I hope you're ready. Okay, so let's begin. So you may have remembered in your math class the expression PEMDAS. This is a very important expression. You might be thinking, well, what is it again? Well, hopefully you remember. If you don't, that's totally fine. We will be going over it today. So I have this basic question of simplify the expression 2 squared plus 3 times in parentheses 5 minus 2 in parentheses plus 8 divided by 2 times 4. And you may be thinking, whoa, that's a crazy question or a crazy expression, but it's not too bad. I'm just gonna have you go ahead and try and solve it yourself. So please pause the video and try and solve it yourself and see what you get. Go ahead. Okay, so if you remembered, PEMDAS is an acronym for, or a mnemonic tool to help you figure out what order you're supposed to do the orders of operation. First one is parentheses. So parentheses, well, in this expression right now, we're going to do the first thing we're going to do is everything in the parentheses. And as you see, 5 minus 2 is the only thing in parentheses. So we're just going to go ahead and do that. And that equals 3. So I'm going to go ahead and write this over here just so I can make this really clear. Okay, so we have this, and we're going to do parentheses first. So we have 2 squared plus 3, and then 5 minus 2 is 3 plus 8 divided by 2 times 4. Great, so we have this right now. And then if you remember the second part, what the E stands for in this case, it's exponents. Exponents. So if we're looking at the second line right here, you can see that the only exponent is this 2 squared. Well, 2 squared, or 2 times 2, is equivalent to 4. So we're going to go ahead and simplify that. Okay. And then, so that was pretty easy. The next part, it's a two-part thing. So this, the order of operations, PEMDAS tells you what order you're supposed to go. So you're supposed to do parentheses first, exponents, and then the third tier, or the third, I guess, after you're done doing parentheses and exponents, the next step you're supposed to do, or order of operation, is both multiplication or division, depending on what comes first. And you might be thinking, what do you mean, what comes first? Well, in algebra, or in math, we always go from left to right. So just like reading from left to right. So that's what we do. So whatever comes first, whether it be multiplication or division, we do that next after we've done all the parentheses and exponent simplifications. So let's go ahead and look. Well, 4 plus something, that's not multiplication. 3 times 3, that is something. So plus 9 plus, so 8 divided by 2. That's the next thing we're going to do. Again, we're reading from left to right. That's very important. So we're going to do 8 divided by 2. And then we're left with times 4. Okay, well, the next thing we're going to do is do 4 times 4. And we're going to go ahead and do that, and it's going to be 16. 4 plus 9. And then the last part we have to deal with, the AS, is add and subtraction. This is the last tier that you'll be working with. So anything that has to do with addition or subtraction, you'll be doing that step. And again, you're reading from left to right. So whatever comes first, whether it be addition first or subtraction first, you do that from left to right. So 4 plus 9, we'll do that first, which is 13. Then we're left plus 16. And we're left with the final answer, 29. Okay. So this was just review on, again, the order of operations. And PEMDAS is a great thing to remember. I still remember it even from middle school or elementary school when I learned this, and it has stuck with me. So if you can create some mnemonic devices that will help you out, go ahead and do it. Get creative with it. So the answer is 29 for this expression. I hope you got that. If you didn't, that's okay. Now, I hope you understand what the order of operations mean. Okay, so let's go ahead and move on to the next subject. So algebra, in all cases, or in all of math, you should be very comfortable with algebra, or at least be very familiar with it. Algebra, usually we're manipulating an equation to solve for it, as in trying to isolate a variable, or just kind of manipulate it into another way. So that's what it means. Algebra. What is the value of x? So in this case, we have if 3x minus 12 equals 24, what is the value of x? And I'm going to give you the same opportunity to solve it on your own. So go ahead and pause the video and try and work it out. Go ahead. Okay, so we have this equation, 3x minus 12 equals 24. And if you are not very comfortable with algebra or you need some review, we can go ahead and just catch you up on that. So we actually move backwards. When we're trying to solve for something, especially a variable x, or trying to move parts of the equation on the other side, we have to move backwards. We have to do reverse order of operations. So if you remember, the last thing we do in PEMDAS, or the order of operations, is subtraction or addition. So we're going to do that first here for algebra, or when we're solving for x in this case. So, well, addition or subtraction, we want to get x by itself. That's the big thing. And, well, if we want to get x by itself, we have to move the 12 over. And moving the 12 over, it's attached to x by subtraction. So we're going to do the opposite of that. We're going to try and add it to both sides, equals 36. Okay, so there's nothing that's added or subtracted from x on this side, so we're done with that part. The next portion is multiplication or division. That's the next step. And as you can tell, if we want to get x by itself, we are going to have to divide 3 on both sides to get x on its own. And that's the only thing we have to work with. And 36 divided by 3 is just 12. So x is 12 in this case. But if you had a more complicated equation that had to do with exponents or parentheses, that's what you would have to keep on going until you can isolate x. So if x was in the parentheses, and there were exponents, you would kind of work your way up until you can isolate x in the parentheses. Okay, so that is how you solve for x in this case. Very simple algebra, but you should be very familiar with it, if not already very comfortable. This is going to be very, very prevalent on the exam. This is the foundations of everything that you will need to know on the SAT math portion. Okay, so let's go ahead and move on to the next topic. So algebra with words. What does this mean? Well, let's go ahead and read it. If 1/4 of a number is 10, what is 1/2 of the same number? So I'm going to give you some time to try and work it out yourself. Go ahead and pause the video and try and get the answer. Go ahead. Okay, so you pause the video. Hopefully you could get to the answer. If not, that's fine. We're going to go through it. So what does this mean? Algebra with words. A lot of the time on the new SAT math section, they want to make sure you can comprehend what they're saying in words and translate that into the symbols that you know of, that you're probably very familiar or more comfortable with in math. So this is what it all means. This is what it translates to. Is means equal to, it refers to the symbol, of times product. Any of those words refer to the multiplication sign. More, sum, addition, less, difference, the subtraction sign. Ratio, quotient, out of will be division. And then what, or an unknown, you'll be dealing with a variable x, y, z, etc. Okay, so let's look at this question and see what it, see if we can break it down. So 1/4 of a number. Okay, so 1/4 of a number of, great. So 1/4 of a number, what, it's kind of the unknown. We don't know what we're dealing with right now. So 1/4 of a number multiplied times, let's just say n, a number, is 10. Well, is means equals to, well, is 10. That wasn't so bad. As long as you understand what the words can translate to into the symbols, it's not too hard. So let's go ahead and see what the question is asking. What is 1/2 of the same number? So they're asking now, what is 1/2 of the same number? Well, okay. All we need to do is solve for the number, and then we'll know what half of the number is. Pretty simple. And we can go ahead and use this first equation we built or got from the question and solve for n. Well, to get rid of, to get n by itself, or to get rid of the 1/4, we'll multiply 4 on both sides. And we'll find that n equals 10 times 4, which is 40. Great. So n equals 40. Oh, we're not done here. What is 1/2 of the same number? Well, 1/2 of 40 is 20. This is our answer. Okay. So there will be some questions that deal with words. Be very familiar with being able to translate the words into an equation. It's going to be very easy to do if you know what they mean. So go ahead and memorize this table. It's going to be very helpful. Okay, so let's go ahead and move on. Okay, inequalities. A lot of people seem to be a little scared when it comes to inequalities because you're dealing with different symbols and it's not an equal sign anymore, which confuses people. However, don't worry, don't fret, it's not too hard. Okay, so if negative 3x plus 6 is greater than or equal to 18, which of the following must be true? So I'm going to give you some time to go ahead and look over the question and solve it yourself. Go ahead and pause the video and go ahead and do so. Okay, so now we're just looking out of these options, which of this is true. Looking at the answers, that's going to be our big hint of how we're supposed to approach this question. Well, looking at the answers, we can guess that we're supposed to isolate x or solve for x. Well, what's nice anyway is that there's also another table that can help us out with inequalities. If you're not familiar with some inequalities, you should memorize this table. You should know what is greater than, and it can go either way. So in this case, is greater than, if you remember in elementary school or middle school, they always say, you can think of this arrow as an alligator mouth. And wherever the alligator mouth is opening to, that is the greater amount. So for example, 10 is greater than 2, or the alligator is eating 10, meaning 10 is greater, because the alligator is hungry and wants to get the most it can. So in this case, is greater than. Less than, we'd flip it like this. 2 is less than 10. So, and when you see a line underneath, this means is greater than or equal to. So be aware of that. And finally, this is very important. When you have a negative x, and you want to try and make it positive x. Well, when you're doing that, you have to make sure when you're making this negative x to a positive x, you're switching signs and you have to do it to both sides. But if you're switching signs on both sides, you also have to flip the sign. As you can tell, so x was less than negative 4, or negative x was less than negative 4. If you flip both signs on both sides of the equation, you must flip the sign as well. So now x is greater than 4. So bear that in mind when dealing with inequalities. A lot of people do get this wrong just because they forget to flip the sign. So do not do that. Okay, so let's go ahead and solve for x. And so what's nice is that we can treat this inequality just like an equal sign. We can go ahead and solve for x the same exact way that we do for any other type of equation that's not an inequality. So that's very nice. Nothing changes. So we're going to go ahead and subtract 6 on both sides. We're going to get -3 is greater than or equal to 12. And then we're going to divide by -3. And here's the thing. We are flipping a sign essentially. We're making it from -3x to just x, positive x. We're flipping signs. So what does that mean? We're going to have to flip this inequality as well. So x will be less than or equal to -4. Oop, make this a little clearer. -4. So just be aware that this is very, very crucial because a lot of people gets this wrong. Okay, so this is the answer right now. And if we look at the answer choices, we know that A is the correct answer. And you can go ahead and check your work. Again, get comfortable with it now. On the test, you don't have time to really check your work all that often, especially with these easier problems. You should be able to comfortably move past them really fast and know you got the right answer without checking your work. So right now, before the exam, you should be practicing and practicing to make sure all these easier questions you can get quickly and make sure that it's 100% correct. So you can check your work by just plugging in, well, -4 into x. What you'll see is that it has to match this inequality. Well, -3 times -4 is positive 12, plus 6 is greater than 18, so it's equal to 18. That's great. That's what we want. We want to make sure that we're greater than 18, or greater than or equal to 18, this side of the equation. And lower the x value, so it has to be lower than -4, because when multiplied by -3, it will become more positive. So keeping that in mind. Okay, so this is for inequalities, not too hard. Please go ahead and memorize that table and make sure you understand what it means. If, again, you had to translate a question from words into an equation, you should be able to do that very easily. Okay, so let's go ahead and move on to linear equations. So linear equations do pop up a lot on the new SAT Math, and you should be very familiar with them. You've covered them in your math course, and I hope you are, if not familiar with them, if not at least familiar with them, very comfortable in doing a lot of problems. So we're going to go ahead and look at a problem and see what you got. So if a line passes through point 3,5 and point 510, what is the equation for the line? So I'm going to go ahead and let you solve this on your own. Go ahead and pause the video and try and get the correct answer. Go ahead. Okay, so we're looking for an equation. Well, especially when we're given 2 points. You have to know a line generally represents a linear line, a linear equation. And as this is shown, mx plus b, m is the slope. So y equals mx plus b, plus b. You should be very, very familiar with this equation. In this form, m will equal, or the coefficient to x will equal the slope, meaning how much it will go up per 1x. And then b is the y-intercept, or the starting point. You'll have a lot of story problems that may deal with the y-intercept. And you have to also think, well, in a linear equation, b is equivalent to y-intercept or just the starting point for word questions. So bear that in mind. Okay, so what we got, we need to figure out the slope first. We're given 2 points. Let's go ahead and figure out the slope. And if you have to know these two equations very, very innately, it should be second nature to you when you see a question like this to be able to come up with the slope equation as well as the linear equation in your head. So slope will equal y2 minus y1. So y2, let's just say it's 10 minus y1, which is 5. over x2, which is 5 minus 3, which is x1. And let's go ahead and simplify, which is 5 over 2. Great. So 5 over 2. So we have this question right now, and, or I'm sorry, we have the slope right now, and the last thing we have to figure out is the y-intercept. We don't know what b is, so we're going to go ahead and use one of the points to plug in to this equation using the slope we found to solve for b. And so let's use 3, 5. We'll use y is equivalent to 5 in this case, and we know the slope is 5 over 2, and we know x, when y equals 5, must be 3 plus b. And we're going to go ahead and solve for b. So let's go ahead and simplify this, multiplying a fraction. So you can think 3 as 3 over 1, and you just multiply straight across. So 5 times 3 is 15, equals 2 times 1, which is 2. And go ahead and do that. Okay, so then we're going to subtract 15 over 2 on both sides to get b by itself. And we're going to get 5 minus 15 over 2 equals b. We're going to go ahead and make sure we get a common denominator, and we're going to change this up into 10 over 2. So 10 minus 15 will be negative 5 over 2. We're going to keep the denominators the same, and that equals b. Okay, so we have b and the slope. So we just plug it into that y equals mx plus b equation. So y equals 5 over 2x minus 5 over 2. That is the equation for the line that passes through those 2 points given. Okay, so it's not too hard of a question. You should be very, very comfortable with this. So go ahead and make sure you go through a lot of practice problems with this type of question. Okay, let's go ahead and, let's go ahead and move on to the next topic. Okay, go ahead and erase this. Okay, linear equations, perpendicular and parallel lines. So we're still dealing with linear equations, but a lot of the time they'll ask you some different things about the linear equation, whether it be a story problem or a problem like this, whether the two lines are parallel, perpendicular, or sometimes neither. So let's read the question. If you have y equals 2x plus 4 and 2y plus 8 equals 8, 2y plus x equals 8, are the two lines A, perpendicular, 2, parallel, or C, neither? So go ahead and pause the video, try and solve this yourself, and then we'll go ahead and tackle it together. So go ahead. Okay, so I hope you were able to get it. If not, it's okay, we'll tackle it together. So you have to remember that what these two terms mean, perpendicular and parallel. Perpendicular means two lines intersecting at a point and they create a 90-degree angle. That's what that means. But for all intents and purposes, we don't really need to know that for the math SAT. Not too much anyway. What you do need to know is that the slopes between the two lines that you're given, the slopes between them, they are, when compared to each other, are negative reciprocals of each other. And what that means is that M1, for example, if it's 4, then we know it is perpendicular if and only if the other line has a slope of negative 1/4. And we just took the reciprocal of 4, which is 1/4. We just flipped it into a fraction. So you can think of it like this. And we flipped it over and it becomes 1/4 and negative. We made it negative 1/4. If this is true, then we know it is parallel. So 4 equals negative 1/4. These are the slopes. And if that's the case, then they are perpendicular. Okay, so that's what perpendicular means. Parallel. Parallel lines mean two lines that will never ever touch. two lines that are next to each other that will never touch, meaning they have the exact same slope. They're going up the same exact rate, so they have no chance to ever cross. So when you're given something like this, you might be given another type of question that asks you, are these two, how many solutions do these two lines have? And you're given like 0, 1, 2, 3, maybe an assortment of possible answer choices. Well, if we know two lines are parallel if their slopes are the same. Well, solutions, again, when solving for two lines is when they intersect. However, if they're parallel, then they will never intersect. So there are no solutions forever for parallel lines. So if you're given a question, for example, that has to deal with two lines and they ask you how many solutions it has, and you find out that both the lines have the same exact slopes, well, that means they will have no solutions because they are parallel. So keep that in mind. And then you have this other option of neither. They're neither parallel, neither perpendicular. And so a lot of the time, they can just be any sort of line that just intersects. So they can intersect at 45 degrees, 70 degrees, and such. So all that, or another option is that they're the same exact equations. They're infinite solutions. And that's the time that you have to just keep in mind that it'll be infinite solutions, because if they're the exact same lines, they will be on top of each other. So keep that in mind as well. Okay, so to solve this problem is get it into point-slope form, or slope form. So y-intercept slope form. So we have this. We know that this equation has a slope of 2, so m1 equals 2. We're really looking at the slopes because, again, that's what determines whether they're going to be parallel or perpendicular. So this other equation we have is unfortunately not in y-intercept slope form, mx plus b form. Let's go ahead and change it into that. So we're going to subtract x on both sides. And then we're going to divide by 2 to get y by itself. And it's going to end up looking like, and so you can separate the two fractions like this, and then you can go ahead and, simplify it. Reduce 8 over 2 into 4. 4 minus x over 2. And now, if you see the slope for this equation, it is negative 1/2. As the coefficient for x is negative 1 over 2. You can think of it as coefficient for, on the numerator side, to be 1. So if we're looking at this, you can see they're negative reciprocals of each other. So the answer is that these two lines must be perpendicular. Okay, so when you're dealing with this type of question, make sure you get it into the y-mx plus b form just to see the slopes. And then you can determine whether they're going to be parallel or perpendicular. Okay, so that is how that is it for linear equations. We're going to go ahead and take a look at factoring out a greatest common factor. So it's very, very important for you to be able to do this. If you see this, you should go ahead and do it. But first, let's look at this expression. Go ahead and try and simplify this expression shown. I'm going to give you some time. Go ahead and pause the video and try and solve it yourself. Go ahead. All right. So a lot of the time, what we have to do is factor out. It's a very prevalent question, or a really prevalent step in the new Math SAT. If you can factor out something, then do it. It's going to be a great first step. If you can see anything that you can factor out, go ahead and do so. And what we're going to do is find a greatest common factor. What is something that is in both the 2x squared and 4x? If you look, there's 2. You can factor out a 2 as well as an x from 2x squared and 4x. Let's go ahead and do this. Okay, so we're left with that. And factor out, again, is just another way of rewriting this. If you go ahead, so you're essentially dividing out a 2x from 2x squared plus 4x, and it's left with x plus 2. To transform it back into 2x squared plus 4x, what you can do is go ahead and multiply 2x back in, and you'll get 2x squared plus 4x again. So just be aware of what's happening there. So if you're looking, we have a 2x and on the numerator and the denominator side. You can go ahead and cross those out, and we're simplified with x plus 2. Okay, so this is something very important. It's a foundational thing on the Math SAT to be able to factor out something. You're going to find a greatest common factor and factor it out. And if you can do it, just go ahead and do it. It's going to be a really good first step or first approach into solving a problem. So please go ahead and do that. Get a lot of practice with this and being able to recognize what you can factor out. Okay, so let's go ahead and deal with percents. So let's go ahead and read this question. It's a little harder of one, but it's a little harder question, but I don't think it's too bad. So Jim pays $5,000 for rent for 1 year. That is pretty cheap rent. I want to live where he's living, or maybe not. The rent then increases by 10% every year thereafter. How much will Jim pay for the first 3 years for rent? Okay, so again, pause the video and try and solve this problem. Go for it. Okay, so percent. What does percent mean? Well, percent means a lot of the time we're breaking something down into 100. Per cent means 100. We're breaking it down into 100 little pieces, essentially, and figuring out how much of the part is of the whole in terms of 100. So you can think of it like that. That's what percent is. And so let's go ahead and tackle this question. Well, we know that Jim is paying $5,000 for rent this year. Well, okay. And it increases 10% every year thereafter. How much will Jim pay for the first 3 years for rent? So we're trying to look for how much he will pay for the first 3 years. So year one, we already know he's paying $5,000. Okay, well, how about year two? We know that rent is going to increase by 10%. Well, what we can do, looking at this equation, so this is a long root. You should be very, again, comfortable with percents, whether it was, you're trying to calculate your own exam score for a quiz or a test, something like that. So you should be very familiar with this, but we'll kind of run through it. So the part, let's see. So we know right now that, let's see, the whole is 5,000. 5,000 right now. And then times 100% equals 10%. This is how much of, so we know it's going to increase by 10%. We're trying to find how much, what 10% is of 5,000 essentially. So this is just a kind of a longer way of going about this, but what you're going to do, do not forget to change the percent to decimal when calculating. So 10% should be transformed into 0.1, and this is done by dividing by 100 on both sides, and you're going to get part over 5,000 equals 0.1. We're going to go ahead and use algebra just to, again, we're going to multiply 5,000 times 0.1 to get how much his rent will increase. And 0.1 times 5,000 is just 500. So his rent will increase by $500. So year two, he's going to pay $500 more than he did in year one. Well, that's easy. 5,000 plus $500 is just going to be $5,500. And as you saw, we just multiplied the percent by the amount of rent he paid that year. So let's go ahead and do that to get how much he'll pay for the third year. I'm going to go ahead and erase this. So now he knows, or we know that he's paying $5,500 for year 2. Then the rent again increases by 10%. So let's just go ahead and multiply how much he's paying for year 2 to get how much it will increase for year 3. So 5,500 times 0.1 is going to be $550. So we're going to add that to the year 2 rent to see how much you'll pay for year 3. So 5,500 plus 550 is going to be $6,050. So this is how much he's paying for year 3, $6,050, year 2, $5,500, and year 1, $5,000. Okay, well, we're asking for the total. How much will Jim pay for the first 3 years? We're just going to add that up, and it ends up being $16,550. Okay, so this is percent in a nutshell. It was a harder question, but I made this on purpose because a little harder because I think you should be very comfortable with these types of questions. I went through in a little more detail, but you should be hopefully very comfortable with tackling these types or these this level of difficulty by now. If not, that's totally fine. Just go ahead and make sure you understand what percent means and just get a lot of practice with all the questions that we have provided for you. So, okay, this is percent. Let's go ahead and move on to system of equations. So system of equations, we're going to focus on elimination. So if 3x plus y equals 13 and x plus 6y equals negative 7, then x minus y equals what? Okay, so again, I'm going to give you some time to do it on your own. Pause the video and tackle it yourself. Go ahead. Okay, so elimination. Go ahead and set it up like this, where the x's and y's are on top of each other and all on one side. A lot of the time for elimination, you will be using elimination for a system of equations, meaning you have two different equations and solving for when they intersect graphically, or just when the x and y will make these equations true for both equations. So I generally like doing elimination when the problem already gives me the equations having the x and y all on one side. So if it's like that, I would proceed with elimination. That is my opinion. However, if you're more comfortable or faster with substitution, go ahead and do it that way. We will be covering that in the next slide. But right now, elimination, let's see how we can do this. I like doing elimination by adding the two together. And what we have to do is get rid of a variable. So when we add these two equations, we should be getting rid of a variable. However, as we can see, if we add both these equations together, a variable doesn't cancel out. So what we do is multiply by a constant if that does not occur in the beginning, to make sure that a variable cancels out when we add them together. And I'm going to try and cancel out x. So I'm going to multiply negative 3 through the entire equation so that I can cancel out the x. So 3x plus negative 3x will cancel out. And we can have only one variable remaining so we can solve for that one variable. Okay, so I'm going to go ahead and multiply negative 3 through the entire bottom equation. So I'm just going to write out the first equation up here. And the second equation is negative 3x minus 18y equals positive 21. And do not forget to multiply negative 3 times negative 7. This is a very common mistake. Do not forget to go all the way to the other side and multiply the constant on the other side of the equation. Please do not forget to do that. Okay, so we're going to go ahead and add these equations together. 3x plus negative 3x will cancel out. Y plus negative 18y will equal negative 17y equals 13 plus 21 will be 34. Okay, so we have that. We're going to go ahead and solve for y by dividing negative 17 on both sides. And we're going to get y equals negative 2. All right, this is the first part done. We have y now. We need to get x. And in order to get x, all we have to do is take what we found for y, the value for y, and plug it back into one of the original equations. And then solve for x. So let's go ahead and take the first equation. You can choose either equation is fine. However, I'm just choosing the first equation. So 3x plus negative 2, because we're substituting in y. We're going to get 3x by itself. We're going to add 2 to both sides because this is negative. And we're going to divide by 3. We're going to get x equals 5. So we're not done yet. Again, do not forget to actually answer the question. We went through a lot of things. A lot of people are like, on the math SAT, they just get really antsy or really kind of nervous, and they do this. They do all this, and they find a multiple choice question that matches one of these and then chooses it, which is sometimes okay, but for this type of question, it's asking what is x minus y. Do not forget to actually answer the question. So x minus y, which is negative 2, will equal 7. So this is the answer to this question, and this is how you do elimination. Again, you're just trying to eliminate a variable, so we'll have one variable to solve for, and then once we solve for that one variable, we plug it back into one of the original equations to solve for the other variable. Okay, so this is how you solve for elimination, or solve this system of equations by elimination. Okay, let's go ahead and go through the other method, which is substitution. Okay, substitution. Substitution is exactly how it sounds, but I'm going to go ahead and read this question first and let you tackle it by yourself. If y equals 2x plus 4 and 3x plus y equals 9, then what is x plus y? Okay, go ahead and try and tackle this yourself. Pause the video and go ahead. Okay, so substitution is exactly how it sounds because we're substituting in a variable with an equivalent expression. So what we know right now, I underlined that because this is really nice because they isolated y for us already, y equals 2x plus 4. And we have this other equation that has everything on one side, which is 3x plus y equals 9. It's very easy for us just to substitute in 2x plus 4 into this y, because we know y equals 2x plus 4. Well, let's go ahead and do that. So 3x plus 2x plus 4 equals 9. We have this now. Great. And since this is being added, we can just pretend the parentheses are not there. And let's go ahead and combine like terms. And we'll have 5x plus 4 equals 9. We're going to solve for x. Minus 4 on both sides. We'll get 5x equals 5. Divide by 5 to get x. We'll get x equals 1. Great. And this last part is very similar to elimination. We're going to take what we got for this variable, plug it back into one of the original equations, and solve for the other variable. And I suggest putting it into the first equation, because the y is isolated already. So it makes it very easy for us to solve the y when we plug in x. Well, we'll do y equals 2 times 1 plus 4. Well, 2 times 1 is 2, and 2 plus 4 is 6, so y equals 6. And just like the last question, we're going to do something extra. We're doing what is x plus y? Well, 6 plus 1 is equal to 7. So that is the answer for this question, and this is how you approach substitution. Substitution, I will recommend you to do it when a variable is already isolated. If you go ahead and do that, it'll save you an extra step. So please get used to these types of forms. Again, elimination, you're going to be trying using it when all the x and y's are on one side of the equation for both equations, while in substitution, one variable is already isolated, makes it very nice for you to substitute them in. So, okay. So this is how you solve for system of equations using either of those two methods. Now we're going to go over something that a lot of people just tend to make a lot of mistakes in. It's a very, very basic, very simple thing, but it's very foundational. It's a lot of people's favorites. 4/3 of Americans get this wrong. I said that wrong just to make a point. Fractions. Fractions are a very, very, very difficult for a lot of people. However, we'll go over it and kind of go over the steps to make sure people, or you guys, have it down and have it be very comfortable with it when you approach it on the Math SAT. Okay, I'm going to erase this real quick. Okay, so fractions, adding and subtracting. Simplify 4x over 3 minus 2x over 2. So I'm going to go let you go ahead and try and solve for this question. Pause the video and go ahead. Okay, so this is how you go ahead and approach this. So when you're adding or subtracting, make sure you have to have a common denominator. In this case, we do not have a common denominator. So we're going to go ahead and try and make one for both those. So we have to try and find the least common denominator. A lot of the times that means we're going to find the least common multiple between the denominators. And if you remember, it's just a multiple that both of them share together. And if you're thinking, well, what's a multiple that both 3 and 2 share? It's 6. So in order to get 6 on both parts of the equation, we'd have to multiply this entire equation by 2 over 2. And this allows us just to change the form. If you remember, 2 over 2, what does that equal to? You probably know it's 1. So 1 times anything is just itself. We're just changing the form, not necessarily like what the equation means. So, and to do this on this side of the equation, we're going to multiply by 3 to make sure we get a common denominator. And we'll get 8x over 6 minus 6x over 6. What's going to happen? We're going to then add across the numerator and keep the denominator the same. Very important. So 8x minus 6x, 2x. Great. And we'll keep the denominator the same. It's 6. And simplify if possible. This means if you can reduce the fraction by finding a common denominator between both the numerator and denominator, then go ahead and do so. And as you can see, the greatest common factor between 2 and 6 is 2. So divide by 2 for both sides, and we'll get x over 3 as our answer. This is how you add or subtract. Again, adding, you would just be adding the numerator side. Okay, so please get comfortable with adding and subtracting fractions. It does pop up a lot on the Math SAT because it is a fundamental thing that a lot of people get very confused with. So just be prepared. Okay, let's go ahead and move on to multiplying fractions. So simplify 9y over 3 times 3x over 2. Go ahead and try and solve this. Pause the video and go ahead. Okay, so my recommendation is simplify each fraction if possible. That's going to make it very easy for you to have a simplified answer in the end. You won't be working with such big numbers. So 9y over 3, well, we can simplify this into just 3y, right? Times 3x over 2. What's really nice is that multiplication is just super easy. We're multiplying across. So 3y times 3x is going to be 9xy over 1 times 2, which is 2. That's our answer. And simplify if possible. In this case, we simplified in the beginning, and it gave us an answer that was already simplified. So it's very nice in that way. Okay, so this is how you multiply fractions. Very, very easy. Nothing too hard. Just don't get it confused with adding or subtracting. It is different. Okay, so let's go ahead and move on to the last part of fractions, is dividing. So go ahead and tackle this yourself. Simplify 3 over 4 over 9 over 7. I'll write this out a little bigger for you. So go ahead and simplify this. Pause the video and take a shot at it. Okay, so here are the steps that I think of when dividing fractions. You can think of it as 5 over 4 divided by 9 over 7. This is another way of thinking about it. And then multiply by the reciprocal of the second fraction or denominator. So what you're going to do is just... Wow, those are awful arrows. Let's try that again. There we go. Reciprocate it, meaning just flip-flop the second fraction, and then you can just multiply. So in this case, so you can think of it like this, and then boom. Okay, so you have it like this, and we just covered how to multiply fractions. Well, 7 times 5 is 35 over 4 times 9, which is 36. Simplify if possible. However, you cannot in this case, so the answer is 35 over 36. And that is how you solve this question and deal with dividing fractions. Not too hard. Okay, so make sure you have a very good understanding of fractions. They do pop up on the exam, not on the exam, but on the SAT, so please make sure you get comfortable with them. Okay, so radicals and square roots. So simplify square root 50 times square root 2 over square root 5. I'm going to give you some time. Go ahead and pause the video and tackle this yourself. Go ahead. Okay, so what you need to know are just some rules. Multiplying two radicals, so multiplying square root x times square root y is equivalent to saying just putting them under the same square root. So that's pretty easy. And same here. I don't know if you can see this. I don't know why it's not showing up as big on the screen, but this is also an equivalent way of writing a fraction. So we can go ahead and do that. Well, let's write square root 50 times 2 under the same, and we'll do this in a later step, over square root 5. Well, what's square root 100? What is square root 100? Well, what's 50 times 2? It is 100. Square root 100. And then we can go ahead and, well, combine it with square root 5, and it will equal square root 20. However, you can think of it a different way. You might have saw a different way of going about this. You could have just said, well, what's square root 100? It's just 10. Great. You can think of it like that as well. So another way of going about it would be, I'm going to go ahead and erase this, but you would get square root 20 as your answer. You could do 50 times 2 is 100. Square root 100 is just 10. And you would just have this as your answer. But however, you can't have a radical on the bottom of a fraction. That is a no-no. So what we'll multiply by is square root 5 over square root 5. And that will end up being 10 square root 5 over 5. Because square root 5 times square root 5, that will cancel out the square root because it's the same thing as saying square root 5 squared. And you're left with 5. We can go ahead and simplify this to 10 over 5 to 2 square root 5. So this is another way of going about it. However, if you went about it by just doing square root 20, that's totally fine. I want to show you anyway how to simplify a radical when given it in this form, square root 20, and simplify it even further. So let's go ahead and look how to go about that. So square root 20, simplify square root 20. Well, go ahead and pause the video and try and work a way out to solve the answer. Go ahead. Okay, so this is the steps that you need. So find the largest perfect square factor under the radical sign. So what's the largest square factor we can have out of 20? Well, if you're thinking, writing out all the factors, largest perfect square, which perfect squares are 4, 9, 16, 25. And you can think, well, it's like 2 times 2, which is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25, and so on. Those are perfect squares. So another way of writing it is 4 times 5. Because the largest perfect square is 4 in this case. And we're going to write it, put it into its own radicals. As we saw in the last rule, we can go ahead and do that. And square root 4 is just 2. And that is how you simplify a radical. These are the steps to take. Okay, so these end up showing up on the harder portions of the test. Once you usually get to an answer, it's usually not part of the answer choices listed. So what you have to do is end up simplifying it, and then after simplification, you end up seeing an answer that corresponds to your own work. So it all ties in the end. Okay, so this is how you go ahead and simplify radicals and square roots. We're going to go over the last thing. I know it was a long lecture video, but bear with me. It's the last thing. It's very important. Average, median, range, and mode. Okay, so last problem we're going to be dealing with. We're dealing with average, median, range, and mode. This is very important, and so you've probably heard of these terms, but let's go ahead and look at this question and see what we got. So what is the average, median, range, and mode of the set of numbers given? If the outlier is removed from the set, what will change the most out of the range, median, and average with the new set of numbers? So it's 2 questions. Go ahead and pause the video and try and solve for both questions. I hope you can get it. Work hard. Let's see what you got. Okay, so what we have now is this question, and you need to know what the average, median, range, and mode mean. It's very important. So let's go ahead and go over that. Mode is the most, meaning out of the set of numbers, what occurs the most frequently is the mode. So we'll go ahead and look at what that is in a bit. Median is the middle. Median is the middle, meaning that if you have a set of numbers organized from smallest to biggest, smallest to greatest, what you end up doing is picking the exact middle. You're going to cross off the beginning, lasso 1, 1, 1, 1. So the median in this case would be 5 out of this set of numbers. What you're doing is finding the exact middle point. Okay, so that is the median. Average. Average you're probably very familiar with. It's what you're doing is adding all the set of numbers together and dividing by the number of numbers in the set, meaning just the amount of numbers that are in there, are in that set of numbers. I guess I don't know why I was trying to rearrange my words. So anyway, that is the average, and the range is the difference between the min and max. So that's what these four vocab terms or math terms mean. So you should memorize this. If not, or if you don't have this memorized yet, please memorize this. You need to know it and be able to calculate them. So looking at this, what you're going to find is that the average, if we add up all these numbers, 3, 4, 5, 6, 8, 9, 9, 10, 15, 15, 15, 45, add them all together and divide by how many numbers are in the actual set, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. You end up getting 144 over 12, which equals 12. So 12 is the average. Okay, and so the median, again, we're going to go ahead and do it like last time, or do it like we explained in the last slide. We're going to go ahead and, so 1, 2, 3, 4, 5, crossed out the first 5 numbers in the beginning. We're going to do that in the end. 1, 2, 3, 4, 5. So, and then what you'll find is that these two in the middle, they're 9, 9. So the median is just going to be 9. Okay? And then the mode, the range. Range is the difference between the max and min. Well, the max ended up being 45, and the min ended up being, or the minimum ended up being 3. So 45 minus 3 equals 42. So that is the range, 42. And finally, the mode, it is something that happens the most often, which is 15, because it happens 3 times, while everything else happens less than that. So the mode is 15. Okay. So that's how you solve for each, the average, median, range, and mode. But now that you are asked a second question, if the outlier is removed from the set, what will change the most out of the range, median, and average with the new set of numbers? So the outlier, as you can imagine, out, meaning the farthest away from the entire set, you can tell that looking at this set of numbers, 45 is the outlier. So what you're going to go ahead and do is take it out, and let's go ahead and calculate the average again, the median, range, and mode. What you'll find is that the average will end up being 9. The median will end up being 9. The range will end up being 12. And the mode ends up being the same, but we're not asked for that. And you're asking what will change the most out of these 3 options. Well, as you can see, the range changed from 42 to 12. It's a huge jump. 30 went 30 units, essentially. It has a difference of 30 units. That's a lot. The median change didn't even change, and the average just changed by 3. So what will change the most? Generally, whenever you try and get rid of the outlier, what will change the most will be the range. So that is something you bear in mind. The range will change the most. The second one that will change the most, the second most changed term will be the average, and then the least changed term will be the median out of these 3. So it'll be range, average, median. Okay. So that is it for this lecture. I know it was a long lecture. I'm glad you bared with me. I hope you were able to pick out some things that you were able to learn and be able to at least refresh some of your previous math experience. You have to know all these types, all of these different points that I presented to you in this concept lecture. It is very important, and many questions, especially the easier half, will be presented to you on the new Math SAT. So please, if you found anything that was a little difficult for you, go back, review, and practice those types of questions. It's going to be very, very helpful for you to score the best possible score you can get. Okay, well, great job today. Hope to see you here next time.